Ever thought of what happens to waste once it reaches the dustbin? Are we correctly disposing of waste? Does waste matter? Approximately 62 million tons of waste is generated annually in India. This is estimated to increase to 165 MT in the next decade and 436 MT by 2050. At present, 70% of this waste gets collected and only 19% of the waste finally gets treated. 50% of this waste usually ends up in a dump yard or a landfill. India requires 1,240 hectares of land per year to dump the current amount of waste generated. However, by 2030, this requirement will increase to 66,000 hectares. So, imagine a world where waste is not processed and is disposed of in an unsystematic manner. Then, in due course, we will all be buried under solid waste. So, what is the need of the hour? To salvage this situation, it is important to end the system of dumping and concentrate on its proper management. The Swachh Bharat mission, launched in 2014, aimed to address the challenges associated with municipal waste management and develop appropriate systems. But is waste that complex an entity? Municipal solid waste consists of dry waste, wet waste, and domestic hazardous waste. In addition, there is construction and demolition waste. Dry waste includes glass, paper products, plastic, metal, wood, and even e-waste, which is generated in households, commercial establishments, and institutions. These can be recycled and processed into value-added products. The non-recyclable waste components and inert are disposed of to scientifically designed sanitary landfills. Wet waste is biodegradable or organic waste, which mainly comprises kitchen waste. This can be converted into rich manure through the process of composting or through biomethanation. Domestic hazardous waste includes sanitary napkins, diapers, toiletries, insecticides, etc. Then there is the more complex electronic waste, which should not be thrown into a dustbin and must be sold to organizations providing services related to extended producer responsibility. For these e-wastes, new mandates were announced in 2016, which focused on ensuring that if such wastes were found to be mixed with municipal solid waste or is pertaining to orphan products, then it must be properly segregated, collected, and channelized to authorized dismantler or recycler. The waste management framework follows a hierarchical approach based on the principle of 5 R's, which is reduce, reuse, recycle, recover, and remove. In this reduction of waste, its sustainability is preferred the most, and its removal and disposal at sanitary landfill is the least preferred. The main aim of every municipality is to close the loop of waste management and promote recycling of waste. So, what are the basic steps of waste management? A bird's eye view of waste management value chain involves 6 essential steps, namely waste generation, segregation, collection, transportation, processing, and scientific disposal. Waste is generated when a material which is no longer in use has served its purpose and is discarded. This can be at the household or generated in bulk in apartment complexes, malls, offices, hospitals, hotels, universities, and like places. The next step involves segregation of waste. Before any material can be recycled, it needs to be separated and sorted. Separation can be accomplished at source of the waste or at a central processing facility. However, segregation is most effective if done at source. Previously, citizens were unaware about the benefits of source segregation, but with the introduction of the new SWM rules, many cities have now adopted this practice. The next steps are collection and transportation of waste, which is done door to door or at collection points with the help of small mechanized and non-mechanized vehicles. Further, it is transported to processing sites or disposal sites via larger covered vehicles. To improve its monitoring, The garbage collection vehicles have a GPS tracking system which helps monitor the location of the vehicle at all times. The next step involves using an appropriate method for waste processing and recycling. This depends on the composition, quantity and quality of the waste. The final step is safe disposal of rejects or inerts in a scientific manner. Every link in the waste management value chain is interrelated. The efficiency of each stage depends on the successful implementation of the previous one. Now that we know the different kinds of waste, the steps involved in its management, we must acknowledge that there is an intrinsic habit amongst the citizens to use one bin for all garbage. This ends up mixing dry, wet, recyclable, domestic hazardous waste and even e-waste in one bin. Hence, one of the biggest concerns in urban India has been the segregation of solid waste. Several studies have shown that India primarily generates a little over 50% of wet waste compared to other types of waste. This biodegradable waste has the potential of generating high revenue. To this end, the government is aiming to promote and enforce source segregation for the effective waste management and to reduce the pressure on landfills. Mixed waste leads to higher residues, adding a financial burden to the waste management value chain. Let us now understand the various methods of waste processing. A constructive way to promote source segregation has been encouraging home composting. If individual households or apartment complexes make it a habit to segregate and compost wet waste, it will offload a huge task from the ULBs, and in return, they'll get a high-quality compost which can be used as manure for the gardens. Availability of various technologies has made this possible, but we still need to know how to do composting at home. It is a fairly simple process. Choose and invest in one of the various available technologies, install it in a dedicated space in your house, segregate your waste, initiate composting processes using a suitable accelerator, and within a stipulated time, get the final compost. Many large establishments such as apartment complexes, hotels, shopping malls, institutes, and offices focus on decentralized methods of composting. A variety of technologies allow bulk waste composting for communities to compost within their premises. For the success of the unit level and decentralized level of composting, it is important to generate an awareness amongst the stakeholders and conduct behavior change activities through effective IEC programs and capacity building. Also, ULBs need to adopt mechanisms to enforce, supervise, and monitor the system by engaging civil society organizations. A decentralized approach to waste processing reduces the cost of transportation and the dependency on dumping yards. However, for newly developed cities, the decentralized method is being encouraged. However, a few bigger cities still continue with the practice of centralized composting due to the large volume of waste generated. In such cases, centralized method is cost-effective, requiring less manpower, machinery, and transportation cost. Another decentralized method of processing is biomethanation for the processing of wet waste. Energy from waste is the crucial element of biodegradable waste. The installation of waste to compost and biomethanation plants helps reduce the load on landfill sites. Let us see how biomethanation works. Biomethanation is the anaerobic digestion of biodegradable waste which is treated in an enclosed space under controlled conditions of temperature, moisture, pH, etc. In the absence of oxygen, microorganisms break down the organic matter into a stable residue and generate a methane-rich biogas in the process. This biogas can be used as a source of renewable energy to produce electricity, and the solid residue can be utilized as manure. Before we begin with the dry waste processing methods, let us first understand how dry waste is recovered. Once the wet and dry waste is segregated, the dry waste is stored in material recovery facility and the dry waste collection centers. Here, once again, sorting takes place. The recyclable waste from MRF are sold to authorized recyclers. The ones fit for processing are transferred to their respective processing plants. The main function of the MRF is to maximize the quantity of recyclables while producing materials that will generate the highest possible revenue in the market. Construction and demolition waste is a new inclusion post the guidelines announced in 2016. These are residues of constructional, demolition, and restructuring activities of civil structures. Although the exact data is not known, roughly, India produces 100 million tons of construction, demolition, and excavation waste material annually. Recycling of C&D waste can help reverse its detrimental effects on the environment and cut cost in producing building materials. Within solid waste management domain, bulk waste generators play a significant role. As per Solid Waste Management Rules 2016, the bulk waste generator includes all gated communities and institutions within an area of more than 5,000 square meters, such as residential areas, commercial establishments, government and public sector or private bodies, social infrastructure having an average waste generation rate of more than 100 kilos per day. Bulk waste generators need to ensure that their waste is managed and treated within their premises. Urban local bodies play a crucial role in monitoring the implementation of guidelines and bylaws set out in the SWM rules for 2016 for bulk waste generators. But what happens when a city does not have the space to install so many processing units? Many cities have adopted the concept of an integrated solid waste management facility or an ISWM. This gave rise to the need for a comprehensive and effective waste prevention, recycling, composting, and disposal technology to manage municipal solid waste and at the same time be economically viable and environment friendly. Integrated Solid Waste Management Facility is the kind of centralized processing facility where segregated waste can be directly brought and treated as per the type of waste. The ISWM systems are designed to suit the local needs and conditions of a city. Solid and liquid waste resource management is a community-based model which suits the needs of a specific community and is also managed by them through SHGs. Let us see the steps in which the SLRM functions. SLRM is beneficial due to its integration of source segregation, promotion of community participation, and implementation of user-friendly technologies. In addition, it provides the opportunity to generate livelihoods, especially for women. The last step of processing waste is isolation and disposal of solid waste residue and inert waste in a scientifically designed and controlled facility, which ensures that the waste does not seep into the groundwater, nor does it hamper the environment. But what happens to the existing dump yards, which were not scientifically designed? Corrective actions for dump yards which have been existing for a long time are being done across the nation. They are treated in a process known as bioremediation. Let us see how bioremediation takes place. The first step is to excavate a dump, loosen it, and make windrows so that leachate can be dried off naturally. Composting biocultures are then added for decomposition. After completely drying, waste is screened through sieves of different size to obtain refuse-derived fuel or RDF and compost. The obtained compost is ready for use and the RDF is sent to cement factories. Through this process, many cities in India have converted their dump sites into recreational spaces. Innovation is the latest buzzword everywhere, and it has found its place in waste management as well. Across various cities of India, ULBs have come up with innovative methods for waste management in order to reduce costs and cater to the local needs. and find revenue-generating solutions, highlighting the concept of waste to wealth. Let us look at a few innovative waste management methods prevailing in India. The waste management value chain is incomplete without mentioning fecal sludge and septage management, or FSSM. Fecal sludge or septage is the slurry that contains both solid and liquid waste accumulated in septic tanks. It results from the collection, storage or treatment of a combination of excreta and black water. FSSM is a systematic approach towards building a sustainable and environmentally safe infrastructure for all components across the sanitation value chain of non-networked households. FSSM involves collection, treatment, safe disposal, and reuse of treated septage. To understand how FSSM is done, let us see the steps involved. The first step is collection, which is the safe removal of septage from on-site sanitation systems. In urban areas, different situations prevail that facilitate or restrict the collection of septage from septic tanks. Generally, the services are made available on a scheduled basis or a call for service basis. The collected fecal sludge is then transported to treatment plants using a vacuum truck or a non-mechanized vehicle and a small tank. The collected fecal matter is dumped in the vacant land or water bodies. The government is enforcing new laws to ensure that this collected fecal matter is treated properly and is reused for other purposes. It is then treated at a dedicated fecal sludge treatment plant. In a few places, it is co-treated in a sewage treatment plant. A variety of mechanized and non-mechanized processing technologies are used, some including constructed wetlands, anaerobic digestion, and waste stabilization ponds. In the end, septage is also reused as an energy resource in a few places. The manure produced after composting can be used as a soil conditioner, and treated liquid waste is reused in gardens and parks. This completes the cycle of waste management value chain. Now we know what happens to waste once we throw it in the bin, and what a useful resource waste can be, and why waste matters in our day-to-day lives.